Okay, all right. So basically this was about, so this first part of the book, that is written by Joe Race and Matt Housley, right? It's from O'Reilly Publications. So I'm trying to tell only the relevant points that is important for us, right? So the first part of the book really talks about um, introduction to data engineering, about data architecture, what should be a good architecture, how to design a good data architecture, right? And how to choose the technologies, right technologies for the data architecture for a company. So that is the main objective of the first part of the book. It talks about the data life cycle, what are the steps there, all that kind of stuff. All right, so let's go on. I've condensed one chapter into one slide, so like 4 slides we have approximately. Okay, so the first one, so data engineering, like everybody knows, it is the upstream process of analytics and ML and AI, right? So it is the steps that a company takes to develop and implement the pipelines or the processes that take in raw data and produce high quality, consistent data that can be used for downstream use cases, right? That is data engineering. So like we have the Maslow hierarchy of needs. So there is the data science hierarchy of needs. And if you see the last 3 steps, which is the instrumentation, logging, sensors. So this is all the IoT stuff where the source data is being collected from. And this is all the um, logistic stuff, where it is being moved. And here it is where it is being cleaned and stored. All these last 3 steps would fall into data engineering, right? The fourth one, it is halfway in between analytics and data engineering, right? And then the fifth one is mostly halfway in between analytics and ML, and sixth one is AI, right? So that is how they have categorized the hierarchy of needs. So data engineering falls in the last 3 steps, right? So this is a very short history, right? So we had it all started with the data warehousing concepts that started in 1990s, right? That was the SQL stuff that was developed then, right? Then in early 2000s is when we had Google develop the Google file system, the MapReduce, all that stuff. So Hadoop happened in 2000s, right? So at that point of time, Amazon was equally doing, simultaneously doing EC2, S3, the simple storage buckets, Elastic Compute, uh, DynamoDB, which is the NoSQL database. All that stuff was going on at Amazon, right? So that was when the cloud was starting, or the distributed computing rather was getting, expanded. Then in 2000 and 2010s is the actual cloud, right? The big data engineering, where we moved from batch processing to real-time processing, with the stream processing, right? We moved from GUI-based tools to code-first, based tools, right? That transformation and shift happened in 2000 to 2010s with, a lot of other Spark and stuff like that. And we are now in 2020s where we are trying to create modern data stacks, right? By piecing together a lot of different individual tools, right? That do well on their areas. We are trying to piece them together and to create a seamless architecture that is loosely coupled, right? So here we are mainly concerned about safety. So we have lots of regulations like the California, data protection regulation, all that kind of stuff. So we are more concerned about privacy and security, and we are looking at creating loosely coupled architectures than a monolith one. That's a single one that can do everything, right? So that is in short the history. Now this is the main part of it. So here's where we have to think about what stage is the company for which you're trying to create a data architecture or trying to do the data engineering work. Where is the company on this life cycle, right? Essentially, so what is their maturity on this life cycle is what you have to think about. And then accordingly, we can ask a lot of questions, and based on which we can decide what we should do, right? So this life cycle understanding this is important. So if you look at the life cycle, data is being generated, it's being ingested, transformed, and served for different use cases. And storage is a common theme across all these stages, right? During ingestion, temporary storages, right? Staging, transformation, and then for serving it's on production, right? And the undercurrents while we do this whole process is 7 important ones, right? Security, data management, data ops, architecture, orchestration. So orchestration is basically you interconnecting different platforms together so that the data can flow, properly, right? Then comes software engineering. So the data engineer needs to be aware of all these things while they do this uh, in in today's environment, right? So if you look at, okay, let's go one by one and we'll look at a few questions that we might want to ask, right? So if we say generation, we can't do much because it comes from whatever we want to get data from. But storage is something that we need to consider mainly, right? So if you look at storage, so a few questions that you can ask are, so what is the characteristics of the data source? Okay, is it an application or is it a IoT swarm? Right. So based on that, the storage technologies and the architecture you might want to design might change. If it is an IoT swarm, it's going to be a real time or streaming, kind of stuff. If it is an application, it's most likely a batch processing kind of stuff. Right. So so how is the data stored on the source system? So is it persisted long term or is it temporary? Right. So that we might want to carry it over quickly, right? That consideration. Um, at what rate is the data being generated here, right? So how many GBs per second, for so that you can design your pipeline to handle that data loads, right? So how often do errors occur? So will the data contain duplicate? These are all, common questions. So what is the schema of the data? So if it is, so based on the schema, we might want to go for different types of DBs, NoSQL, SQL, right? So a lot of different types of DBs based on the schema. And if a schema changes, right? So how is this dealt with in our system that we are designing, right? Uh, so what kind of uh, processes we are bringing in so that we can handle that schema update from the source systems, right? So there are something called stateful systems, right? That basically tell you, um, so last time you checked in here, we were here. Now this is the status. So we have changed it by X amount. So that is the stateful system, and that's the information it gives you, right? So it's called change data capture. It captures the changes, and it's mostly relevant for finance kind of stuff where you have changed the revenue, changed the profit, all that kind of stuff, right? So if you're dealing with a stateful system, right? So is the so what is the logic for tracking the source database that you have to incorporate into your data architecture, right? Will reading from the source impact performance of the source? So if you keep on reading repeatedly from the source to store data, how is that going to affect the performance of the source system, right? So these are, different kind of questions that you might want to ask on storage, right? That will kind of give us ideas about what kind of a storage system you want to use, how much load it should capture, and what are all the processes or fail-safe process that we might want to incorporate when something goes wrong in the source system. And finally, are we disturbing the source system in any manner by reading it frequently? So this is the summary of the stuff that was discussed in storage. So the question that we might want to ask while designing a storage system. Was that clear, or was I too fast?
Sunny, when you mention disruptions in source system, what does that mean exactly?
Okay, so let us say you're dealing with an application or an API, right? So if you keep on repeatedly posting large queries to the API, right? So does it fail at some point? If it fails, then how much time does it take to re uh, come back on track? Okay, so if it is an IoT system, a sensor, or something like that, if we keep on posting repeated requests to get the latest data, is that affecting the performance of the sensor in any way? Inadvertently, that we don't want it to affect, but if it gets affected, we should know. right? That kind of stuff. It is more like testing the capabilities of the source system so that we can behave accordingly, that we don't disturb it.
Okay. Yeah, understand.
Okay, all right, yeah. So moving on to the next one, right? The next one will be yeah. So if you want to look at some other questions, right, for ingestion, right? So ingestion is the pipeline that you develop from the generation system to the source storage system, right? So that is the pipeline in between, right? So here mainly what you have to be concerned with about is these two, the starting point and the ending point, and you should be behaving in a way that will not disturb any of these two functions but can perform its ability, right? So the first main question here is the storage solution compatible with the architecture's required read and write speeds that the ingestion is going to handle, right? So you have to pick the tool. So here comes the piecemeal approach where you're picking different tools and you're piecing them together, right? So this is what you should be concerned with specifically in this case. Is it able to be compatible with the read and write speeds that you want it to work, or is there a bottleneck somewhere, right? That affects this because the ingestion's main work is to transfer data, and if it can't do that, then it's going to be a problem, right? So um, so what is the scale or anticipated future scale, right, on the ingestion system and the storage system, right? So what is the read operation rate? What's the write volume? These kind of stuffs would come into picture. Um, and will all the downstream users, okay, be able to get data according to their SLAs? So they have some requirements that they want from the data team. They have some requirements that they have to comply to, right, for the organizational rules and stuff for accessing data or all that. So is the ingestion system meeting all that um, SLAs, right? Are we capturing metadata as well while we extract data from generation systems and storing it in storage? It is the ingestion system's job to capture metadata as well, right? So what is the data lineage? Data lineage is more like tracking history or auditing of data over time for the same data point, right? That is data lineage. So it has to consider it a data lineage. It has to consider the um, data flows, right? So that we can have a complete understanding of the data and what route it has taken in the past while we analyze it. So that's why the metadata and the lineage comes into picture, right? Um, yeah, so that is majorly the stuff that we might want to consider for uh, ingestion, right? And
So, Sina, one quick question about data lineage.
yeah,
What all aspects are covered under lineage, and what kind of benefit does it give? Can you just
so okay, yeah, sure, yeah. So say for example, there is a specific use case that I'm currently working on, right? Where we are looking at the backlog numbers, right? I don't want to mention anything more technical or from the client side, but yeah, in general. So we are looking at backlog numbers uh, for my project. That basically how much amount of work have been paid for by the clients and we are yet to do. That's the kind of numbers that we're looking at. So this number changes as and when a company signs new contracts. That means the client has paid for it, but they're yet to start work, or it changes whenever the work is being done and invoices are being raised. So the backlog number goes down, right? So at any point in time, if we can only look at what is the current backlog number, right, then that doesn't have a data lineage, right? So what happened in between two time points, how many new work or new projects were signed and how many invoices were raised, right? If we can have this all together, right, then that gives us some idea about how the backlog changed, right? So data lineage especially comes in when we are tracking this backlog number over time in the system itself. Instead of us having to do manually the work to see how many new projects were raised and how many, invoices were sent out, and then do the math and figure out what happened. If you're tracking this number over time, then that becomes data lineage. So
Got it. Got it. So
yeah,
basically, I mean, this is a question for you and for everyone else also. So have you guys seen in the tools that you are operating right now, for example, like in Snowflake or maybe any other tools that have you seen facilities for data lineage tracking? See, if you actually made a, let's say, new table and you took some information, let's say from sales data or some other data, and you put it there, you don't know where it came from unless you go and look at the query, right? So my question is, have you seen in any of our companies, our client companies, have we seen facilities for data lineage tracking?
I see in one of the case, Chaitanya, this is more like a Salesforce sort of data. Okay, so
Okay,
customers do change their stage, right? Like, so the moment they move to next stage, they just mark as the stage two. They have the discussion with the customer and they'll mark them again to stage three. So this
right,
sort
right.
of data do have the time steps in it, time stamps in it. So and so
No,
date.
no, no, that's
When
not the question, Akhil. Actually, so what you're talking about is that a case, right, or a lead is being tracked, and you're tracking when that lead has changed over time.
exactly?
Right.
Yes.
I got that point. I think that's a good point. But I was asking a slightly different question, which is, so wherever the data is, let's say the data originated from Salesforce, okay, then came to, let us say, this particular table, right? That is called, let's say, lead status, right? And after that, it has gone to another report, right? So Sina, that is what you're calling data lineage, isn't it? Where has the
yeah, how
data
has
moved?
changed? Yeah,
Where
yeah,
has it come from? Where has it gone?
yeah,
Which shape is it now? Originally, where it originate, and what are the stages it passed, and where did it come to later?
yeah.
Right? Yeah. Okay. All
Because
right,
there are
Sina.
lots of transformation, and if we have lineage, that helps to understand those transformations.
Okay. Okay. Got it. Please proceed, Sina.
Yeah. And one more important question that you might want to ask on ingestion is the the real time versus the batch thing. So there is also something called micro batches, right? If you're using the batch thing, that is at a very small interval, say once every minute or something like that, right? So that is also one possible thing. So you basically have to evaluate. So, will that approach cost more in terms of time, money, maintenance, and opportunity cost, and all that stuff, and then decide between batch and this. So, mostly for reporting purposes, batch thing is fine, right? But if we are doing some um, alerting stuff or, very time critical systems, then that's where real time stuff will come into play. And some ML use cases will also need, and AI use cases will need real time data, right? So, it's basically checking the result of the use case, what we get the benefit of the use case versus the cost that goes into it. Um, yeah, and yeah, like we said on storage. So if you're getting data from a live production instance that is critical, then what is the impact of my ingestion process on the source system is an important question to ask. Moving on to transformation. Here it's pretty simple, the list of questions, right? It's going to be, so what is the cost and ROI on the transformation? Are we doing stuff that is really helpful for the company or not? Right. So what is the business value? These kind of questions start coming in at the transformation stage. So here it was more technical questions, more tool oriented questions, and on transformation it becomes more result oriented questions. Right. So what are the business rules that the transformation has to support? Right. Am I minimizing data movement between the transformation stage and the storage stage? Am I doing unnecessary transformations a lot of times, or am I doing it optimally? Right. So, is there point behind why I'm doing what I'm doing? Is the important question to ask at the transformation stage. Serving two different use cases is pretty much simple. So they might need data on different formats, right? So there's something called reverse ETL. So it is like, so whenever you have taken data from a system, transformed it, and then stored it on a storage, right? And then you're taking the stored data back, right? And you are processing it, and then you're giving it back to some of the source systems, and then it comes out on a new way. So that is like a loop that goes on between the source system and the storage system, right? With transformations in between. That's called reverse ETL. So you're using processed data and you're processing it again, right? So that are some use cases as well. So they might they're saying we want to consider it for those as well, right? So these are different use cases in serving. Um, so yeah, so while doing all of these steps, a data engineer has to be aware of all these things. So data ops is primarily, the ingestion stuff, right? So doing it periodically, handling any issues if it comes up. So what is the, handling all the availability, reliability issues of all these tools, all that comes in data ops. Data architecture is planning the main thing. So what is the skeleton on which this thing will work? Orchestration is linking the tools in between. So what are all the mechanisms we use? So there are some orchestration tools as well, right? But they are at the nascent stage. But mostly we are trying to link these tools if they have the supporting connectors, etc. Or we are trying to link them using an intermediate storage, right? That these tools can access individually, right? So yeah, software engineering is important because for data engineers, because we are now moved into more code first regime, and we are now dealing with a lot of uh, storage and processing systems that need more software coding than uh, analytics kind of coding. Right? Yeah, so that is the main data engineering life cycle, and a few questions that you might want to ask on the respective stages. Can I move further? Any questions? So now talking about good data architecture, right? So while we design the architecture, so what do we have to consider? So it is basically the important point to consider here is it flexible? Is it reversible? Those are the two main questions, right? Because lots of tools are coming in and day out, and lots of tools are getting obsolete, right? So we might be, we might want to be very careful about what is a tool that we are picking around which we are building our whole architecture, right? One or two tools, the main ones, right? If those are transitory and if they go off, then it's going to be a lot of work for us, right? So we have to ensure that we choose the immutable technologies and put them at the center of our architecture, while using all the transient technologies that might come in and go away around it, right? That's how we can be safe and ride the wave as the new tools come in, right? And the decisions we make, we have to ensure it is reversible. It's a two-way door, right? So if we have to come back at some point in time, then we should be able to. So a lot of these tools have data gravity. So once you have moved the data into those tools, right, it is hard to get it out, right? Because you have established a lot of other connections from that tool to elsewhere and all that stuff. So it's going to cost you time and effort, uh, and to get it out and move back. So to reduce that, we have to make sure whatever decision we're taking is more reversible, and we have to plan for it. Yeah, so choosing components wisely, it's basically you don't have to reinvent the wheel. We have a lot of tools available, you don't have to build one, right? But you have to choose. It's a balancing act. So if a data team gives tools that is one size fits all for all the teams for the different needs that they have, then it's going to be not helpful. Whereas it should strike a balance in between facilitating collaboration and the one size fits all stuff, right? So that it kind of helps them, all the individual teams, do the required work, and it's not a hindrance for anybody. Planning for failure. So these systems, a lot of these cloud-based systems, they are, they have availability, reliability issues, right? Except for the few top ones, right? We have to plan for it because these tools do fail now and then, right? So we have to think about what is the recovery time objective, what's the recovery point objective. So basically, if something goes wrong, so what is the time limit in which it should get fixed, right? So what are all the possible steps that we might take to get that fixed, right? Because some of our customers might be depending on these tools running, right? So that will affect them out as well, right? Recovery point objective, if we lose data, right? So what is the acceptable limit that we can lose? So that is the recovery point objective. So these things need to be put in place. Architecting for scalability, right? There are a lot of tools that can now scale up, scale down, and even scale to zero, right? So the important thing here is us deploying inappropriate scaling strategies can lead to high cost and it can overcomplicate our systems, right? So the scaling strategies need to be thought of, right? That is the main point here for scalability. Yeah, architecture is more leadership. So it's like, so data architects, they possess the skill of data engineers, but they don't practice it, right? So they kind of make careful technology choices and spread knowledge to training and leadership. So that's what they mean by architecture leadership. So they have to take that role. Data architects on a company is what they're telling, right? Always be architecting. So there is, at any point in time, architecture is not a fixed role. It's not a fixed, thing or stuff, right? There is a baseline architecture at that point in the current state. There is a target architecture where they might want to go to, and it is the role of the person to create a sequencing plan that works and that also has a safety net at the bottom so that nothing goes wrong. This is a very important point that I like. So building loosely coupled systems. So when we are creating the modern data stack, right, where you are piecing together a lot of different tools, etc., and this is also applicable for companies that have a lot of different teams that have their own data handling capabilities that have to share data across them, right? So so there's something called Bezos API mandate, right? Jeff Bezos sent out an email to all the Amazon teams, right? So he said all the teams should share data only via APIs, right? And there should be no other direct read and write of stuff on other teams' database from some other team, right? You have to create API endpoints and you have to share data only via those, right? And it doesn't matter what technology you use to handle data at your end, but since you're using an API, it only creates an interface that the other team wants to use. So that creates interdependability of tools across teams and all that stuff, right? So what this does is it reduces the risk that a change made in one component creates unanticipated changes on other components of the tool, right? Of a bigger system, right? This creates linkages that are loosely coupled, but each of those nodes functions separately, right? And they can do improvements separately, right? It decouples them a bit, right? With just the necessary linkages traveling across, that's the data. So that is one of the important mandates for the loosely coupled systems. So yeah, like I said, make reversible decisions, use a two-way door when possible whenever choosing a technology or a tool. Right? Now, see, for the 8th point, prioritize security. Earlier, we had the hard-coded perimeter, hard security perimeter on the tools, which is say like monoliths tools that we used, right? You need a, a team to handle security. It is your responsibility. Right? Now, since you're moving into cloud, we have the shared responsibility model where, let's say, AWS takes care of certain points on security side, but they also entrust the data security with you, right? Now, the operational aspects of it they handle, but the permission and the role aspects of it you have to handle. So that's a shared responsibility model, right? So now this line between the line for the security perimeter is slightly disappearing as we move into the cloud-based systems, right? So data engineers have to make sure, they prioritize security. The final one is FinOps, right? Now, a lot of companies have started moving completely into cloud, right? So their infrastructure is no more on their side, but it is translated to cost on their sheets, right? So it is imperative that they create a collaborative working relationship between DevOps team that manages this infrastructure and spins up new one whenever necessary, and the finance team that manages the finances, right? So there has to be a working relationship between these two teams. It's called FinOps. That's what they call it, and so they have to plan together, create budgets and all that stuff. is what they tell. So for a good architecture to be developed, this is also an important point. So these are the main points for developing a good data architecture.